Let's evaluate the limit of a complex fraction. So in our numerator, we have a fraction, 1 over 10 plus h minus 1/10, and then it's all over h. So we have a complex fraction here because our numerator has a denominator. So we're just going to first off try to plug into our limit. If you let h be 0, you get 1/10 minus 1/10 in the top, which is 0, and then h is 0 in the bottom. You get 0 over 0. We have a hole in this. We're going to work to figure out what that finite limit would be for this hole. From a hole, both sides approach the same y value, so the answer is definitely not d and e infinity or negative infinity. It's going to be a nice finite number. It just may be a fraction or a decimal. So when we have complex fractions, we want to find a common denominator so that we can actually do this subtraction here. So I'm going to put a star on this subtraction. We're going to end up trying to subtract our numerators. But to do that, we have to have the same denominator. So I'm going to take the limit as h goes to 0 still and make a common denominator. So we're going to do that by multiplying our denominators with the other side. So we're going to cross multiply. So on this first side, we're going to multiply by 10. And on our other side, we're going to multiply by 10 plus h. Okay, so on the left side, we are going to have 1 times 10, which is 10. Over 10 times 10 plus h. Trying to make a same denominator here. And then we have minus. We have 1 times 10, which is 10. 1 times h, which is h. And then at the bottom, 10 times 10 plus h. All over h still. So I can now, since I have the same denominator in the top, I can subtract those out. So I want to subtract the entire numerator here. Remember, we put a star on that subtraction because that was what we were going to do. We're going to subtract. We need to subtract all the terms. So it has to be distributed. So in the top, we're going to have 10 from the original first fraction. And then we have a minus 10. And then what should we be doing with that h? We're going to subtract that as well. We have a minus h all over our common denominator, 10 times 10 plus h. And then in our denominator, we're still dividing by h, which I don't like. We still have a complex fraction, so we're going to end up flipping and multiplying that. So we're going to flip and multiply, or this might be called keep, change, flip. Flip and multiply. Instead of dividing by h over 1, we're going to multiply by 1 over h. So we have the limit as h goes to 0. In the top there, we can say 10 minus 10 will cancel. So we'll just have negative h divided by 10 times 10 plus h. Instead of dividing the whole thing by h, which h can be written as h divided by 1, we're going to multiply by 1 over h, right? Dividing by 2 is the same thing as multiplying by 1/2. So dividing by h is the same thing as multiplying by 1 over h, which helps me to see that these h's will cancel. And all I have left in the top for my limit as h goes to 0 is a negative 1 over 10 times 10 plus h. And now we can try plugging in h is 0. Into the top, I'm just going to get negative 1. In the bottom, I'm going to have 10 times 10 plus 0. 10 times 10 is going to give me 100. So my limit is going to be negative 1 over 100. So definitely just be careful you distribute this negative to both terms, or else I would have gotten a positive 1 over 100th, which if I wanted to verify using a table of approaching values, I would see that it would be negative 1 over 100. So for instance, you could plug in negative 0.1 and positive 0.1 to plug in values close to 0 into the original function, and you would see that that limit is truly negative 1 over 100.